Hey guys, what's up? Welcome to Tski Tutorials, and this is FPS 1.19. In this episode, we're going to learn how to add Headbob to the character, or that movement of the camera going up and side to side as you're walking to make it look like you actually have like some walking movement to the character and you're not just running around on roller skates. Alright, so to actually do this, the strategy that I went with was to actually use a little bit of trigonometry. So we're going to be using sine and cosine. So before I go farther, let me actually pull up Google and show you what the sine and cosine graphs actually look like. So here is sine of x. So what we're actually going to be doing in our script is we're going to create a variable that is going to constantly count up as our character is walking. So it's just we're going to be able to change the speed at which this number counts up, and it's only going to count up depending on whether or not the player is moving, how far they're moving, and whether or not their feet are touching the ground. And so we're going to actually apply that to sine of x and cosine of x2. So right now here we have sine of x, and this would be the number that we have counting up, this number that is the x-axis. So as it's counting up, it's going to return us a number that just goes up and down between 1 and -1 like this. So this is going to be our left and right movement of the head bob. And let me show you what the horizontal movement is going to look like. Let's see, x times 2. So as you can see, this is almost the same thing, except it starts all the way up at the top at 1, and it goes up and down twice as fast with this equation. So this is going to be the up and down movement of of the camera of the head bob. Alright, so now that we have the sine and cosine equations in place, we need to define a couple of things like how far left and right is the head going to move, how far up and down is the head going to move, how fast is it going to move, are we going to be taking really big slow steps, or are we going to be taking like really tiny fast steps? Okay, so basically what we're going to do is take that sine and cosine equations and actually apply it to the local position of the main character, or I mean of the main camera, because the main camera is a child of the player capsule, and the player capsule is basically like the body of the player. So whenever the player capsule moves or rotates, the camera is going to rotate and move with it. When we change the local position, that's just an easy way of saying where the camera is going to be relative to the player capsule. So when we apply these equations to the local position just on their own, we actually get a problem. What's going to happen is we are going to get that side to side and up and down movement, but the camera is going to be more like in the middle of your stomach or in the very center of the player capsule. So what we need to do is add some height to that camera so that the camera is still at eye level when it goes left and right and up and down, because we're going to be changing the X position and Y position of the player every single frame depending on where we're at in this sine cosine head bob equation. Alright, so let me pull up our text file and let's actually take a look at all the variables that we are going to be using in this script. Let's see, we have 6 variables for this episode. So head bob speed is a number that we're going to multiply by the amount of distance that the player has moved since the last frame if the feet are touching the ground. So that when we make this number larger than 1, this number is going to count up faster. If we make it smaller than 1, the number is going to count up slower. So we can adjust this number in order to make really tiny fast steps or really big slow steps, and we can just make it look just right to exactly how we want the player to look and feel. Okay, our next variable is head bob step counter. So this is going to be a number that we're just going to start at 0 at the very beginning of the game, and we're just going to keep on counting up and counting up and counting up, because it doesn't matter how big this number gets. We're just going to go ahead and let it keep on getting bigger and bigger and bigger, and it's going to count up whenever the player is moving and your feet are touching the ground. And then of course we're multiplying that by head bob speed, so head bob speed affects how fast head bob step counter actually counts up. So the next variable we have is parent last position. Now this is a vector 3. So after all of the code that we have in place that measures the distance we were since the last frame and actually applies it to the position of the camera, it's going to save the position that the parent is actually at right now, so that when the next frame comes around we can access that variable and see the position that the player was at during the last frame, so that we can actually measure the distance between where it is now and where it was. So the next variable we have is head bob amount x or head bob amount X and head bob amount Y. So this is pretty simple to understand. This is just a number that the larger it is, like if we have head bob amount X be very large, our head's going to move side to side a bunch as we walk. And same with head bob amount Y, it's going to go up and down a lot more if we make it a big number. So we can adjust this number to actually make it look and feel just right. So our last variable is eye height ratio. So eye height ratio is basically going to be a number that's going to determine the default height of the camera compared to the player capsule. So the reason why we're using a ratio is because later on we're going to do some tutorials about how to actually make the player crouch when you hold down the shift key. And the way we're going to do this is actually going to be stretching the scale of the player capsule. So we're going to use it as a ratio so that the camera goes up and down with the camera, or with the body, accordingly as you crouch down. So this number is going to be 0, the camera is going to be at your feet. 1 is going to be at the very top of your head. So we need to find a number where it's like a good balance, where you still have some headroom and it's like at about eye height. So I'm guessing we're probably going to want to make this number like 0.9, 0.95, something like that, just so that the camera is basically eye height. So yeah, that's all the variables we have. Let's actually get into the code that we're going to be using. So all the code we're going to be doing today is going to be inside of the mouselook script. So the mouselook script is the script that is actually attached to the camera. So this is where we're going to apply our head bob. So the first thing we need to do is function awake parent last position equal transform dot parent dot position. So basically right now parent last position is a vector 3, and when we declare it and we don't assign it any value, by default its value is going to be 0, 0, 0. So what's going to happen in the very first frame of our game is that it's going to measure the distance between 0, 0, 0 and where the player actually is now, and then you get a huge jump in a single frame, and it's just going to make the camera jump really quickly when we first start the game. So we might as well put this code in place so that the parent last position is the position of where the player has actually started. So our first line of code is if transform.parent.getComponent player movement script .grounded. So basically we're just figuring out whether or not our feet are touching the ground, because earlier in the player movement script we created some script to make the variable grounded go between false and true depending on whether or not our feet are touching the ground. So if our feet are touching the ground, grounded is going to be true. So the way that we're accessing this variable is transform.parent because the main camera is always going to be a child of the player capsule, and the player capsule is the game object that has the player movement script attached to it. So now we have right here we have the transform of the player capsule, and then we do get component player movement script. So we're just accessing the script that we know is going to be attached to the player capsule, and then we're accessing the variable grounded out of that. So if grounded is true, we're going to execute the next line. So this line here is basically the line that is going to make head bob step counter count up when our feet are touching the ground. So the way this works is head bob step counter plus equals vector3 dot distance parent last position transform dot parent dot position times head bob speed. So it looks a little complicated, but it's actually pretty simple. Let me break it down. So the first part of it is vector3 dot distance. So this is a function inside of the vector3 class that just measures the distance between two different vector3s. So the first vector3 we give it is parent last position. So this is going to be the variable that we're going to save after all our code is done. So down here, parent last position equal transform.parent.position. So the position that the player capsule was at during the last frame. So that's our first vector3, and then we're measuring it, the distance between that and the current position of the parent of the main camera, which is the player capsule. So we're just measuring the distance between where it was the last frame and where it is now. And then we're multiplying that by head bob speed so that we can control how fast this number goes up, so we can make really fast head bob movements or really slow head bob movements depending on what we actually want to happen in our game. So the next two lines of code are actually going to affect the local position of our main camera. So the local position is the position relative to its parent. So if the player capsule moves or rotates, we know our local position is going to move and rotate with that. So the first line of code is actually a lot simpler than the second, and we're affecting the local x position. So we're having transform.localPosition.x equals, and this actually doesn't need to be inside of parentheses. That's a little redundant. But we have mathf.sign Headbob step counter. So if you remember that equation that I plugged into Google earlier, it's basically just as that number counts up, it's going to give us this number that goes up and down between 1 and -1, and it's going to curve between those automatically. So that is going to be the actual head bob movements. So that's the number that's going to go between 1 and -1, and then we're multiplying that by head bob amount x, so the actual amount that the head is actually going to go side to side. And then I am multiplying that by current aim ratio, so that when you are aiming, the head bob is a little bit less, especially with guns where the aim ratio is very slow. You're going to have a lot less head bob. But if the current aim ratio is the same as holding at the hip, you're still going to get a lot of head bob. So the head bob is going to be dynamic depending on which gun you're using. Okay, so our next line of code is actually going to affect the local Y position of the camera, or the up and down movement of the head bob. So let's break it down. It's actually two big parentheses that are added together. And inside of the first set of parentheses, we have mathf.cosine head bob step counter times 2, head bob amount y times -1 times current aim ratio. So basically what we're doing is, first of all, we're just accessing mathf.cosine, and we're doing the head bob step counter and multiplying it by 2 so that it goes up and down twice as much as it goes left and right, because every time you take a step, your head goes up a little and down a little as you take that step, and your head's going to go left to right once as you switch feet. So your head's going to go up and down twice as much as it goes left and right. So that's just a very general head bob sort of pattern. I don't know how realistic it is, but it looks pretty good in the game. And then we're multiplying that by head bob amount y, so we can change just how much the head goes up and down so that we can adjust it and make it look realistic. And then we're multiplying it by -1, so that the head, instead of starting way up high, it actually starts way down low, so that we actually get that up and down movement with each step, so that they're just synchronized. And then we're multiplying it by current aim ratio, just like we did head bob, or just like we did the local position of x, because we want the head bob amount to be less if we're using a gun that needs a lot of accuracy. Alright, now let's take a look at the two sets of parentheses that we're going to be adding and subtracting. So the first set of parentheses that we're going to be adding is transform.parent.localscale.y times I height ratio. So we're accessing the parent of the transform, and the parent of the transform, as we know by now, is the player capsule. And then we're going to access the local scale of that, which is basically how big we've stretched the character and just the height of the character, or that's where the point y comes in, or dot y. We're accessing the y axis of its local scale. So basically this is just the number of units of how tall our character is. So when we multiply that by I height ratio, so if we just have transform.parent.localscale, we have the actual height of our character. When we multiply that by about 0.9, it's going to bring the camera down to the height that we actually need. So now we actually need to minus half of the height of our character, because right now actually 0, 0, 0 of local position compared to where our player capsule is actually going to be in the very center of the character, not at the very bottom center. It's going to be in the center of the height. So we need to minus half of the height so that we're actually measuring from the feet up. And that's where this comes in, which is transform.parent.localscale.y divided by 2. So we're just taking the y scale of our character and we're just dividing it by 2. and we're minusing that from this, let me highlight it right, from this whole thing, so that we're starting from the feet and not from the very center of the body. Alright, and our last and simplest line of code is this right here, and that's parent last position equal transform dot parent dot position. So after all of our code is said and done and executed, we're going to save the position of where the actual player capsule is during the current frame, so that when we access it during the next frame, we can access where it was during the last frame. So we're just saving where it is now so that we can access it later and remember where it was, and compare it up where is it? Compare it up here so that we can measure the distance between where it is now and where it was during the last frame. So yeah, that's all the code we need. So I'm going to cut the green screen and go straight to Unity and show you how to do that inside of Unity. Alright, here we are inside of Unity, and let's take a look at what the game actually does right now. So as you guys have probably noticed, there is absolutely no head bob. So it pretty much just looks like we're running around on roller skates. So yeah, let's fix that. So we're going to open up the mouselook script, and let's start with those variables. Whoopsies, okay. So the first variable, what was it? It was, why can't I remember? Was head, I'm gonna make head bob all one word. Head bob speed float, and I'm gonna start this off at 1, and the next we had was the head bob step counter float, and we don't need to assign a value to that because we want it to start at 0. And now we have head bob amount x float, and let's have this amount, be, we'll start it off at 1. I don't know, we'll change it later. And head bob amount y float equal 1. We'll do the same thing because we're going to adjust it later. And then what was the last one we needed? It was, let me open up the text edit file so that I can see what it was. Oh, parent last position and eye height head ratio. Okay. So, and then we need var parent last pose, and that is going to be a vector 3. And then eye height ratio float, and I'm going to have that be 0.9. Okay, so first let's start with the function awake. And all we need to do is set the parent last position to equal the parent's position where it is now. Transform dot, transform, did I spell that right? Transform, there we go, I knew it was spelled wrong. Dot, parent's lowercase. Alright, so we just saved the position of where our parent is in the very beginning of the game. So now let's add some of our other code. If I remember right, the first thing was an if statement that said if we are grounded. So we're going to do if transform dot parent dot gets components player movement script. Cool. Okay. Dot grounded. So now if our feet are touching the ground, we're going to execute this next line of code, which is going to be head bob step counter plus equal vector 3 dot distance. So we're going to measure the distance between the next two vector 3s, and those are parent last pose, and the parent actual position where it is now, transform dot parent dot position. And then we're going to multiply that all by Headbob speed, so that we can actually change how fast this number goes up and down, so that we can change how quick our Headbob movements are. And then what did we need to do after that? I'm going to go back to text edit and cheat. Okay. We need to actually simply apply the actual local position. So transform dot local position dot x equal mathf dot sine, wait, yeah, sine is capitalized, sine of Headbob step counter, and we're going to multiply that by Headbob amount x. And I'm pretty sure that's all we need for that line of code. Let me just double check. Yes. No, oh, current aim ratio. I knew I was forgetting something. So we want this amount to actually change depending on whether or not we are aiming. So that is current aim ratio. Current aim ratio. Okay, now let's actually affect the y. So transform dot local position dot y equal, we need to put this all inside a parenthesis, mathf dot cosine of Headbob step counter times 2. And we're going to multiply that by Headbob amount y, multiply that by -1, so that it starts at the bottom rather than the top, so that it looks a little better. And then we need to multiply that by current aim ratio. Okay, so that's the first parenthesis. Now the second one is going to be the actual y position of where we want the camera to be relative to the very bottom of the feet of our character. So what was that? Transform dot local, oops, not what I meant to do, holy crap. Okay, dot local scale dot y times eye height ratio. Alright, cool. And now let's minus half of the height so that we're starting at the feet rather than the very center. So that would be transform dot local scale dot y divided by 2. And I think that is the whole equation right there. And now, if I remember right, we're just going, oops, wrong button. We're just going to do the parent last position now. And so parent last pose equal transform dot parent dot position. All right, cool. I think that's everything we need. Why don't we go into Unity and give that a little test run? There's a compiler error, unknown identifier. Parent last position, I forgot a T in there. Alright, now let's give it a try. Compiler error is gone. Let's see how this looks. Alright, whoa, whoa, whoa. Whoa. Not quite. That does not look right. So there's a couple things we need to do to actually fix this. And it looks like the first thing we really should do is get rid of the mesh renderer so that our player capsule is actually invisible, because we don't want to see it because it's very ugly. And the next thing we need to do is change a few things in here. So head bob amount X, let's change this to more like 0.5, and head bob amount Y, I don't know, 0.3. Let's start with that and see how that looks. A little better. Still not quite. Still too much. So head bob speed, let's change that to 0.2, and head bob amount X, that's still too big. Head bob amount Y, it looked too big to me, so I'm going to change it to like 0.1. Let's see what this looks like now. That looks a little better. That actually looks like walking. So that doesn't look too bad. Why is the gun so glitchy? I haven't had that problem before. Okay, so I figured out why the gun looked kind of glitchy, and let me just play it and show you. So the gun follows the camera, but it just feels kind of glitchy, and I mean, that's all I can explain. It just looks glitchy and it's kind of jumping around. So there's actually a very easy fix to do, or to fix that. So we're going to go to the gun script, and we're going to change function update to function late update. So that way it's going to run through all this code after all of the other code in the game. So it's going to move to the position of the camera after the camera has already gone through its own head bob movement script. So let's go back into here, and as you can see, that got rid of the glitchiness. It actually looks nice and smooth now. And I don't know if you can really see the head bob movement, so I'm just going to increase the head bob. First of all, head bob speed, I'm going to change that to 0.3. Head bob amount Y, I'm going to change that to 0.3, and this to 0.4. And let's see if that's a good looking head bob. That's not very good looking. That's way too much Y. One more adjustment. I'm going to change this to 0.2, and if that's not close enough, I give up. I'll adjust it, make it look good later. I don't know. That looks a little weird to me, but whatever. At least it's not glitchy, and we can fine-tune that later. So as we're walking on the ground, it looks pretty good. Let's actually get rid of maximize on play, and I'm going to zoom into the player capsule, and it looks like we need to increase our head height ratio. There we go, that looks a lot better. Now the camera height is actually at a pretty good level. So let me go back to the main camera and change this. What did I change it to? I don't know, like 1.2. So we're going to do it a little bit more than 0.9, but that looks good to me. So let's actually go back into the mouse look script, and let's hide the variables we don't need to see. So we'll hide this in the inspector, because we don't need to see the head bob step counter. We don't need to see the parent last position. And I think those are the only two that we don't actually need to see in the inspector. So, yep, those are all variables that we're going to want to adjust. And I'd say this game is looking pretty good. Sweet, we actually have head bob, and it feels a lot more like we're walking now. Cool. Alright. So this has been a Tsuki Tutorials FPS 1.19. Stay tuned for the next episode where we are going to be adding gun bob. So just like head bob, except the gun itself is going to be moving up and down and left and right to make it look like we're actually carrying it and like it actually has some weight to it. So stay tuned for that, and until next I just totally stumbled over all my words. So anyways, stay tuned for that. Until next time, I'll see you guys later. Keep making games.